And I think that this should work. All right, the first problem here is a Boyle's Law problem. We have gas in a sealed cylinder with a plunger. The plunger is adjusted so the pressure increases. Temperature remains the same. What happens to the volume? Just remember the basics of Boyle's Law here. Remember we had our piston, just like this. We're going to put more pressure on the piston. When we do that, the volume decreases. That means that the two are inversely proportional. Pressure increases, volume decreases. Back to our question. If our pressure increases, what's going to happen here? Again, remember basic of Boyle's Law. Our volume will decrease. Pressure increases, volume decreases. All right, this is a Charles's law. Remember, Charles's law said that temperature and pressure were directly proportional. Here we are increasing our temperature while the pressure remains the same. That's important. What's going to happen to the volume? Well, if the two are directly related, that means if the temperature increases, the volume must also increase. It's a direct relationship.
How can you tell by the question that this is Charles' law versus Boyle's law?
Well, Boyle, I never use the words in there because I don't want you to have to remember whose law it is. But we have three laws that we work with in the gas laws. First is the pressure volume. They're inverse. The second is temperature volume, and they're direct. And the third is number of moles and volume, and they're direct. So those are the three. This is temperature, so that's indirect.
So
Once
the
again,
clue word there is temperature. The clue word is temperature,
right, that's it.
and then the clue word up there is pressure.
Right.
The
First one, we had pressure. That's inverse. Temperature is direct. And as we'll see in the next question, here we're adding more gas. So that's the number of moles. If you add more gas and you keep everything unchanged, pressure and the temperature unchanged, and you're pumping in more gas, it's a direct relationship. Therefore, Avogadro's law says that the volume must increase.
What law was that?
That's Avogadro. Remember the funny looking guy? Any question on these? Very basic concepts. We have three concepts we're dealing with. Pressure, temperature, number of moles. Pressure increases, volume decreases. Temperature increases, volume increases. Number of moles increases, volume increases. Three basic laws.
What chapter does this test cover? 6?
Oh,
5?
sure.
Does it start at
All
5?
right. Do you have an exam? I put in some extra because I only set one page for you. So.
Okay. Yeah, I have it.
Okay.
This for, we covered in the exam, right? Is this what we covered?
Yeah.
Okay.
So this is Charles's law once again. Remember, Charles's law was the temperature pressure. And the words here are that the two are directly proportional. Now, what I want you to remember in this question is, what do we mean by directly proportional? And basically, it means if one goes up, the other goes up. So which of these equations describes this? When we did the whole Charles's law thing, or all the Nernst law things, remember what we did was we said, instead of the proportionality sign, we were going to stick in an equal sign and a constant. So think in your head, wherever you see an equal and a constant, just put in proportionality. So in our first one here, V would be proportional to T. By gosh, I think that's pretty much what this says. In our second one, V would be inversely proportional, because we're changing this to proportion to T. Our third one, well, if we go ahead and divide this out, that's V1, T2, V2 over T1, that's nonsense. That's nobody's law. And finally, here, we change this to proportionality. That makes no sense at all. So once again, volume directly proportional to T. Whenever you see the proportionality sign, you can put in an equal sign and a constant. So what Charles is saying is V is directly proportional to T. That's the only one that works. Any questions? All right, I always throw in lab questions here too. Here we took the flame, we put salts in there, we got lots of colors, that was neat. Question here is, why do we see the colors? Number one, it's the actual color of the element. Well, that's silly. Of course not. B, we'll skip B. Metal ions are reacting with the flame to produce new colored elements. Well, that's as silly as the first one. And D, metal ions are reacting with carbon dioxide, blah, blah, blah. Remember what we said about this. You have an atom, and the electrons are in various energy levels. You take this poor little atom, and you shove it into a flame. What happens? Well, these electrons get very excited. And when they do, they go from one energy level to another. Now, this electron used to be down here. It's not happy up there. It's an excited state. It will stay there for a microsecond or less, and then it will fall back down. And when it does, it releases the energy it absorbed as light. We have two electrons that I showed here. Therefore, we get two discrete wavelengths of light, a purple and a blue. And the wavelength is dependent upon how high it goes up and then falls down. So going back to our question, the only one that makes sense is B here. Metal ions absorb energy, promotes them to a higher quantum level. When they return, a discrete wavelength is produced. Now, when we did this lab, we used a little instrument. I'm asking you here what it was. Was it a stethoscope, a spectrometer, a spectroscope, a spectrophotometer, or did I just miss it altogether?
Let's see.
Well, a stethoscope looks like that. Doesn't make sense at all, does it?
C.
Doesn't make sense.
C.
A spectrometer. What in the world is that? Well, it actually looks like this. And that's way too elegant for them to allow you to touch. I mean, think about that. A spectrophotometer actually measures absorbance of light at various wavelengths. This is a very simple one. It looks something like this, and we didn't use that. You'll use that in general chemistry and organic chemistry, but not here. So what we have here is a spectroscope. Remember the little blue guy? The tough part was remembering to point this end at the flame and look at this end for the reading. Spectroscope. Any questions? All right, we did another lab where we measured conductivity of things in solution. A strong electrolyte. What happens to a strong electrolyte when you put it in solution? A, it dissolves. Well, it darn well better because otherwise nothing happens, right? B, it dissolves and forms electrocytes. Or C, dissolves and dissociates into ions. So what the heck is an electrocyte? That's a cell in an electric organism. Cyte means cell. This is the cell right here that actually produces the current in an electric field. But it has nothing at all to do with dissolving things in solution. That would be an electrolyte, not electrocyte. So, it's got to dissolve, and it must form ions. Remember, ions in solution are the things that allow conductivity to happen. A and C are both correct. It must dissolve, it must form ions. Now another question on this same lab. Which of the following solutions will be a strong electrolyte? Now you did this in lab. You actually sat there and did this. So you must remember the answer. We had oil in water. We had concentrated HCl. We had sugar in water. Which of these are going to form ions? Clearly not the oil, because it doesn't even dissolve, does it? It just floats on the top. Sugar? Sugar dissolves in water, but it doesn't ionize. Strong acids, however, fully dissociate into ions. HCl will form hydronium and chloride. Stick it in there, lights glow nice and brightly. Concentrated HCl was our strongest electrolyte. Virtually 100% dissociated. Any questions? All right, moving on to our favorite subject, pH. Here we have a solution that's pH 3. What does that mean? That it's basic, acidic, neutral, 3 moles of acid or 3 moles of base. The basic thing we remember is that a neutral solution was pH 7, right? That was neutral. If it's less than 7, it's acidic. If it's more than 7, it's basic. Here's our equation. Our pH is minus log hydronium. Take the antilogs. Here's our 10 to the minus pH, that's hydronium. So if we take 10 to the minus 3, that means we have 0.001 moles of acid. 10 to the minus 3 moles of acid. Neutral water has 10 to the minus 7, doesn't it? So does this have more or less? It has more. If it has more, it must be acidic. pH is less than 7, it's acidic. It's more than 7, it's basic. Exactly 7 is neutral. Yeah?
Less than 7 is acidic, correct?
Less than 7 is acidic. And pH can actually go negative, and it can actually go over 14. Sulfuric acid or concentrated HCl, like 2 or 3 molar, will be pH less than 0. All right, here we're changing the pH. We're starting at 7 and going down to 5. What has happened to the hydronium? Well, here you have to think about what the pH means. Remember, that's the negative log of the concentration. So if we're starting at 7, that means our hydronium concentration is 10 to the minus 7. If we're winding up at 5, hydronium concentration is 10 to the minus 5.
Increasing.
Again, here's our fundamental thing. Ten to the minus pH is hydronium. So we're starting at 10 to the minus 7, and we're going to 10 to the minus 5. Does this mean we increase or decrease acid? We increase, right. By how much? A factor of 100. These two differ by a factor of 100.
Why 100?
We have 10 to the minus 7 and 10 to the minus 5. There are 2 zeros separating the two, aren't there? That's 100. Write it out. 0.0000001 with 7 zeros or 6 zeros, and then 1 with 4 zeros. They differ by 100-fold. 10 to the minus 7, you multiply it by 10 squared, that's 100, you get 10 to the minus 5. I told you to do the exponential tutorial. You simply add the exponents, right? 10 to the minus 7 plus 10 to the minus, plus 10 squared gives you 10 to the minus 5. Simply add the exponents. It's 100.
Decreasing by 2.
Every pH unit, just remember this guy. Every pH unit is a 10. All right, we're going from 7, which is neutral, to 5. So with 6, it's 10 times more acidic. At 5, it's 100 times more acidic. At 4, it's 1,000 times more acidic. Every unit is a 10. All right, simple balancing equation. We have sodium nitrate, decomposing to give sodium nitrite and oxygen. Remember, on the exam, you'll get something that looks somewhat like this. And there'll be little blanks. You have to put in the coefficients, but if the coefficient is a 1, you must put in a 1. Otherwise, I don't know if you just didn't know it or you left it blank or whatever. So put in a 1. All right, so let's balance this. We have 3 oxygens, we have 4 oxygens. That's an odd even, right? So to make this even on both sides, let's stick a 2 in, right? Now we have 6 and we have 4. So they're both even. That's a good start. All right. What have we done here? We just put in 2 sodiums, right? 2 nitrogens. That means we're going to need 2 of these guys on this side too, aren't we? So let's see. 2 sodiums, 2 nitrogens, 6 oxygens, 1, 2, 3, 4, 5, 6 oxygens. I actually think it's balanced. All we have to do to get full credit is to put the 1 in. Any questions? Organic chemistry. We love organic chemistry. If we only have sp3 hybridized carbons, now what in the world, let's think about what that means. That means we have 1 s orbital, 3 p orbitals, we hybridize them together to make 4 equal orbitals. So 4 things, right? When we talked about organic compounds, for the very simple hydrocarbons, we described 3 of them. If we have a carbon with 4 things attached, we said that was sp3, and we call that an alkane. If we took 1 s orbital and 2 p's, we got trigonal geometry. Three things bonded. Three orbitals, three things bonded. We call those alkenes. And if we have an sp, one s, one p, that's two things bonded. That was an alkyne. So if we have four things bonded, our functional group here is an alkane.
Can you go back, please?
So an alkene is three things bonded?
Yep. And you have three orbitals, you form 3 sigma bonds. 4 orbitals, you form 4 sigma bonds. 2 sigma bonds. Remember the other bonds here, the double and the triple, are pi bonds from the leftover p orbitals. 3 functional groups we talked about. Alkanes, where they're all sp3. Alkenes, where they're sp squared. And alkynes, where they're sp. This is an example of a branched alkane. And again, every carbon is sp3. Every carbon has 4 bonds. Every carbon is tetrahedral. Any questions? Well, after organic chemistry, we moved into biochemistry, didn't we? And we said amino acids, what do we know about them? They contain functional groups, lots of different functional groups. But they always contain an amino group and a carboxylic acid. Can they polymerize to form peptides? Are they the building blocks of proteins? And are they the basic backbone in RNA and DNA? So let's look at what we remember here. These are 2 amino acids. This is the amino group. That's an acidic group, the acid, amino acid. Over here, amino acid. We said that we could hook these together by taking the amino group from one, reacting it with the acid group on the other. When we do that, we lose water, and we form an amide. The amide is the backbone. If we continue to hook them together the same way, we get a short group of amino acids all linked together with amides, and we call this a peptide. If we continue the process hundreds of times, we wind up with what we call a protein. Exactly the same, they're just all linked together, and they give us this long chain that's a protein. When you eat protein, what happens? The enzymes in your body break off each of the amino acids, and that's where you get the nutrition. What about DNA? DNA has purine and pyrimidine bases. It has ribose and phosphates, but nowhere in DNA does it have amino acids. Nowhere. So back to our question. Contains amino group, can polymerize to form peptides, are the basic building blocks of proteins, but not an RNA or DNA. Any questions? All right. Remember, on this exam, just like the first one, you're allowed to have a 3x5 card. And you can write whatever you want on it. Equations and little notes to yourself and your friends and stuff like that. Whatever you want. What is the equation that would give you a simple interconversion between pH and pOH? At 25 degrees in solution, pH and pOH are related by a very, very simple equation. What is that? They always add up to 14. pH plus pOH is always 14. Hydronium multiplied by hydroxide concentrations is always 10 to the minus 14, always. And pH plus pOH is always 14.
What was it you said that before that? Hydronium?
If you take the concentration of hydronium ions and multiply it by the concentration of hydroxide, that product is always 10 to the minus 14. Hydronium times hydroxide is 10 to the minus 14. pH plus pOH is always 14. Don't ever forget those. All right, what describes a basic solution? Basic solution, okay? pH is less than 7. Wait a minute, what did we say about pH? It's less than 7 is what? It's acidic. Right. Hydronium times hydroxide. Well, let's just do this. Remember, pH is less than 7, it's acidic. If it's greater than 7, it's basic. That's a very fundamental thing. You can even write that one on your card. Small, very small. Too many words. So our first one here, the pH is less than 7, this is acidic. Now, what did I just say about the concentration of hydronium and hydroxide? It's always equal to 10 to the minus 14. Always. It's not less than or equal, therefore, this is nonsense. If the hydroxide concentration is greater than hydronium, you have more base than you do acid. Wait a minute. Does that make the solution acidic or basic? Duh. If you have more base than acid, it must be basic. Any question? All right, conjugate acids and bases. Remember those guys? What to remember about a conjugate acid-base pair? An acid will lose a proton to form its conjugate base. When it does it, it's going to lose a positive charge. So the base will have one more negative charge. So remember that. Acid loses a proton, that's a plus thing. Form the same compound, but with one less proton, one less positive charge. So, our forward reaction here, we're starting here, we're going this way. Which one is the acid? Which one is the Bronsted acid? Which one donates the proton? Which of these two guys donates a proton? Hydrogen sulfate loses its proton, gives it to hydrogen carbonate to form this. Hydrogen carbonate is a base. It accepts a proton. So this is our Bronsted acid. That's our Bronsted base. All right, for our conjugate acid-base pair, we're looking first for the acid. The acid is hydrogen sulfate. When hydrogen sulfate loses a proton, what does it form? Sulfate. Take a proton off, add a negative charge, what do you get? Sulfate. An acid loses a proton to form its conjugate base. Proton is positive, so it also loses that positive charge, gains a negative. Loses the proton, forms sulfate, -1 to -2. Any questions? All right, gas laws again. We are trying to calculate an unknown parameter. What parameters do we have to work with? Pressure, volume, number of moles, temperature. Those are the things that we work with in the gas law, right? If we're just trying to solve for one unknown parameter, that makes it a single state. Remember, we had two universal gas law equations. One was for a single state, the other was for two states, where you change everything. In a single state, we use PV equals nRT. All right, obviously C is correct. Looks just like this, doesn't it? How about A and B? Yep. If you take this equation, multiply by RT, you get PV equals nRT, don't you? Both of these are correct because these two are the same equation algebraically. If you don't see that, just take this equation, gonna multiply both sides by RT, so it cancels on this side. We have RT in PV, same thing, except backwards. Any questions? All right, I'm almost embarrassed to show this next question because we've said this like 17 times in the last 5 minutes. Which is correct regarding conjugate acid-base pair.
We have one less proton.
One less proton and one more negative charge. You transfer the proton, that means you lose a positive, so that also means you gain one more negative. Acid loses the proton to form its conjugate base. Proton is positive, therefore it's one more negative charge. All right, I will promise you that you will have a question exactly like this on the exam. You'll have a space, and you will show me how you calculate POH, hydronium, and hydroxide. Now our pH here is 12. First thing we want to remember, hydronium is simply 10 to the minus pH. Remember that. Write it on your hand. 10 to the minus pH. So we simply substitute. My gosh, that's 10 to the minus 12, isn't it? So what is hydronium? 1 times 10 to the minus 12 molar. I remember a bunch of questions ago I said, what was the fundamental relationship between pH and POH? What is it? They always add up to what? 14. So if we know pH, and our pH is 12, what is POH? It must be 2.
You have to write that whole thing?
You don't have to write it, but you could.
No, I mean in the test for the
Yeah, well,
answer.
you could. It doesn't take you more than a second or two to do it, does it? Yeah.
So H3O positive equals 10 to the negative 12. That's just common knowledge. It's just automatic.
Yeah, 10 to the minus 12 is the same as 1 times 10 to the minus 12.
Would we get it wrong if we put 10 to the negative 12? Or do we have to put it in that group?
Yeah, you know, this is probably, to express it as molar. You could do this if you put molar after it, I'd be happy, but. And finally, if we know POH and we want hydroxide concentration, what is our hydroxide? It's 10 to the minus POH, just like this, except different, of course. So we substitute for our POH, that's 2. And what's our hydroxide? 1 times 10 to the minus 2 molar. Any questions? You will see one exactly like this, except totally different. And finally, let's wind up with what we know about pH. If we know the molar concentration of hydronium, and we know the molar concentration of hydroxide, which of these are true? We know that if you multiply these two together, we'll get 10 to the minus 14. We know that whether the solution is acidic or basic. We know that the negative log of each, that's the pH or pOH, will add up to 14. Remember, under all conditions, hydronium times hydroxide is 10 to the minus 14. Under all conditions, pH and pOH will equal 14. Negative log is the same thing as pH, pOH. And finally, if we know what pH and pOH are, we know if the solution is acidic or basic. Now, wasn't that easy?
Test gonna be different.
Absolutely. And next week at this time, you are all just gonna clean this up, right? Absolutely. Now, Roy, you asked if I could meet you next, or maybe this Wednesday. I'm actually teaching at that time. So here's what I have to offer. We have yet another simple lab at 6. I'm sorry, yeah, 6, upstairs. After the end of the lab, I will sit there with anyone that wants to come, and we will work through tutorials. If you're having trouble with tutorials, we'll work through them. Okay? That work for you?
This
Yeah.
is when?
Wednesday, after lab. So we'll do our lab, and then we'll just kind of sit there at a bench. And if you have any questions about tutorials, we'll just work through them in real time. That work?
So I can bring my laptop.
Sure.
So number 19,
This is 20.
you know, the one before that one. That one. That one where it says HO negative on top, that's the first part?
That's hydroxide concentration, hydronium concentration, and pOH. You're given a pH, so you know our hydronium. You know that pH and pOH must be 14, so you can calculate pOH.
So the pOH, right.
And if you know pOH, you can calculate hydroxide.
That's the last one, because you have OH.
If you have OH, you just substitute in here, and you get hydroxide.
And the question, it says HO negative.
Right, OH negative.
No, on top it says HO.
It said HO, I don't see. It switched to HO study OH.
It says HO or is it?
Oh, it's all, it's the same.
Same.
Oh,
It's the same.
the same.
Sorry, it's all the same.
Yeah, but you just confused it as me. I said HO.
All right, now we have a whole bunch of tutorials.
Yo.
Remember, you get 5 points for each of these. So make sure you sit down and do all that you
60
can
points.
before next week. He shuts off this time next week.
You connecting these? No.
Yeah,
How many of those tutorials go over like or the solution pH, pOH? How many of those go over?
how many
All
questions
the
on the
way
exam?
I mean, that's
If you actually look at pH2, it's a very good exercise. Because you're given one and you have to calculate all the elements. Try it, if you make it good, it works, and you talk about it on Wednesday.
So everything that's on the tutorial is
Yeah, the exam will look very, very much like this.
So the tutorial is presented.
Tutorials, these are all tutorials.
Right?
without
It has that question, but
So
it,
they just help you
there are
assess
questions,
what's
we
going
don't know the answers.
Did
you get a question from the
The problems that are on the exam are there in the tutorials as well.
No,
No,
not
not
sugar.
the tip one, the
Well,
other.
acid,
You know, you
some
never know,
acid
because
ones.
Yeah, some
Not
of the stuff.
generated
I did it, but some of that stuff was.
Does it let you
Tutorials
do it,
tend to be much more
or
fun.
Yeah.
one time?
than
Let
the
you read
exam.
it a few times.
Oh, okay.
I find myself when I'm doing the tutorials for these upcoming chapters,
Like,
I
private,
find myself doing a lot of math.
Right.
But I didn't have enough.
I'm
And that's
very
right.
lazy.
What acid?
The exam will be much
Did you
more
write what
quality.
acid?
Right.
It was
Like what we
the,
were using,
Okay.
the N-O.
Yeah.
Just make sure you understand the concept.
it said, you talking about when they
So
said.
again, the
times
exam
and-
is,
No,
next
the one you
Monday,
got, that one?
right here, 6 o'clock. Make sure you bring a calculator so you can do your log calculations if you have to. And remember, all the tutorials have to be finished by that time. Any questions?
You click this?
Sure, well, no,
No.
hand in a copy to me, it's 5 points.